So we go to the 5.3 independence in the multiplication rule. So first we have to identify what independent events are. And independent events are simply put an event that does not influence the other event. Simply put, it's an event that does not rely on the other event. That sounds a little bit complicated, but let me give you an example. Um, let's say you're picking out 7 shirts for the week. The probability on the first day that you'll pick out a shirt you like at random is going to be 1 out of 7. But now let's take that shirt out of the mix because we've already worn it once that week. We can't wear it again that week. Well, obviously you can, but for this example's sake, let's say you can't wear that shirt again for the rest of the week. Then on the second day, you only have 6 shirts, and everything else is equal probable because you're choosing one at random, and you get 1 out of 6. So these are dependent events where the outcome of the next trial depends on the outcome of the first trial. So that's what a independent or a dependent event is. An independent event is when two have no connection. So that does sound a lot like disjoint events, but we'll get to that later. So two events E and F are independent if one does not affect the probability of the other, as we mentioned. Flipping a coin once and flipping a coin twice. The second flip has nothing to do with the first flip. You can still get heads if you get tails on the first flip. So these are independent events. No matter how many times you flip a coin, the probability will still be 50-50 every time you flip that coin. So here we have disjoint events versus independent events. And disjoint events and independent events are two different concepts. So two events are disjoint if an outcome cannot be two things at once. But here's the interesting thing, and it's pretty genius. It's kind of like axes of freedom that we've mentioned in Bessel's correction. But two events that are disjoint are dependent. So all that means is that two events that cannot happen at the same time are dependent. Because let's say we flip a coin and get heads or tails. Getting heads and getting tails are disjoint because they cannot happen at the same time in the same trial. So we consider them dependent. And here's why. If you get heads, and if you know you got heads, then there's a 0% chance you have tails. So disjoint events are dependent because the events one event gets canceled out because two of those same events cannot occur at the same time. Sorry for the stuttering, I guess. Let me just rephrase that. So disjoint events are two things that cannot occur at the same time. So we know that if one occurs, the other doesn't occur, and that's why two events that are disjoint are dependent. So here we get to the multiplication rule, and here's how we use it for independent events. So suppose you flip a coin twice. What is the probability you get heads twice in a row? So let's use the classical method, which will determine the number of outcomes. So we can either get heads heads, heads tails, tails heads, or tails tails. So those are the possible outcomes, which will go in the denominator for the frequency. And the probability you get heads is heads and heads is 1 out of 4 because this is one outcome out of the possible 4 outcomes. So we intuitively figure out that the probability of us getting head is 1/2, just on a basic scale. The formula for getting heads on flip 1 and flip 2 equals getting heads on flip 1 and flip 2 divided by the total number of outcomes from flip 1 and flip 2, which would be 4 here. We see the probability is 1/2, 1/2. So if E and F are independent events, then the probability of E and F are PE times PF. And you can scale that further. So like flipping a coin, the probability increases exponentially by a factor of 1/2 to the power of n, which you don't really need to know this for now. But that was found using the multiplication rule. So that's it. All you need to know is that the probability of E and F occurring is P probability of E times the probability of F if they are independent events.